Okay, good morning guys. So for today, we're going to tackle about tawag doon, application. So dito tayo sa pinaka last topic natin. Okay? So application of differential calculus. To be fair, nung tinuro sa akin to nung student ako, wala ako na. Hindi ko alam kung nasaan ako. Baka absent ata or nag-cutting. But anyway, so application of differential calculus. So medyo talaga nangangapa ako nung first time ko siyang tinuro. Nung first ko din nagturo ng calculus. Okay, application of differential calculus. Technically, we have many applications. Pero tatlong topic lang yung i-cover natin. Okay, we have what we call the optimization problems. Okay, optimization problems. Okay, so mostly kung may background kayo sa calculus or kahit saan man, technically ito yung tinatawag natin na maxima and minima. Okay? So it is the minimum or the maximum value of a certain things or object. So ganun din dito sa optimization. So ano yung pinakamalaking area, ganon. Ano yung pinakamalaking length, ano yung pinakamalaking width, ano yung pinakamaliit na width na pwede natin gamitin, yun yung optimization problems. Okay? Next, we have what we call related rates naman. Okay? So, itong related rates na to, hindi lang to nakafocus sa speed. Okay? So, lahat siya. Lahat ng rate. Rate of change, yung pag-decay ng bacteria, mga ganon. Diba? Pag-decay, carbon dating. Okay? Tapos, yung pagbabago ng volume, pagbabago ng radius, and so on. So, yun yung ano natin. So, related rates or rate of change. Okay, and lastly, hindi ko siya na-discuss, pero dapat mag-discuss ko siya. Under siya ng higher order derivatives is what we call, technically, may iba siyang ano pero dito siya, under siya ng rectilinear motion. Okay? So, you remember our topic last physics, guys? Uniformly accelerated motion, di ba? We have how many formula na ginamit doon? 5. Technically, yung 5 na yon, solve. Kung yung physics is based on calculus, technically, we can solve all those 5 solutions or 5 formulas using calculus. Okay? Di ba? Meron tayo ng S is equal to V1T. Tama ba? V1T plus, wait lang, 1/2 80 squared, something like that, di ba? Mga ganyang formula. Okay? So, yung mga ganyang formula, sort of makikita nyo dito sa equation natin. Pero ayun. Okay? So, yan yung tatlong problem na yan yung mga tatlong topics under application of differential calculus yung matatakal natin. Okay? So, first, we proceed with rectilinear motion. Okay? More on sa rectilinear motion, mas magpo-focus tayo sa freefall. Okay? Freefall. Okay? So, hindi ko siya technically na-discuss nung physics natin, pero under siya ng uniformly accelerated motion. Why? Kasi yun din naman yun, di ba? Let's say we have a building here. Di ba? So, ayan. Building tayo. Let's say, 4-story siya. So, yan yung building natin. Pagdating sa free fall, either of the two lang naman yan. Either yung bola, okay, let's say there's a person here, hindi siya tatalon. Let's say meron siyang object dito, pare bola, mas malaki sa ulo niya. So from the term itself, free fall, hinulog niya yung bola with no force. So binagsak niya lang, okay? Kasing green up. So technically, zero velocity at the start. Either yan yung isang problem natin, or what if naman, meron tayong ulit, isang tao naman dito, kaaway niya. So ito creeps, ito bloods. Joke lang. And yung bola naman, yung bolang binagsak nito, binato niya naman pataas. As in pataas lang. Walang project, walang angle, walang curve, just shot up to the sky. Ganun lang. Okay? Binato niya lang pataas, parang nagpa-jump ball lang siya. Okay? So ito yung magiging focus natin for rectilinear motion. Okay. So what better way to discuss mostly all of the application is based on problem solving. Okay? So ayan. Start tayo. First, before tayo mag-proceed sa problem solving. Okay? So technically in Freefall, we have formula that we are going to use. Pero bago natin i-discuss yung formula, discuss ko muna yung higher order derivatives na tinatawag. Diba? Way back, di ko siya nabanggit technically. Okay? So, in higher order derivatives, technically, once you derive it again, there's a new formula na lumalabas doon. Okay? Yan yung pag-uusapan natin. Okay, first, di siya technically tinatawag na first order derivative. So, we call them by their ordinal numbers. First order, second order, ordinal tawag doon First, second, third, ganon. First order, second order, third order of derivatives, fourth order, and nth order of derivatives. So, pinaka-better way to example or pinakamagandang example ng higher order derivatives natin, guys, is velocity. Why? First, technically, we have the distance. Okay, distance or S. So, S yan. S or what we know as distance or displacement. 'Di ba? Nabanggit ko siya way back nung physics time natin na there's a big difference between distance and displacement. So next, once na dinerive natin tong S with respect to time, so once na naging ds over respect derivative of time, technically, diyan na papasok ngayon yung first order derivative natin, which is what we call the velocity. Okay? Velocity or speed. Pero either of the two, interchangeable naman siya pagdating sa math. Kasi we don't, technically, we talk about the directions. Pero sa discussion natin, we only have two directions. Technically, we have the downward and upward. Okay? So, velocity. So next, once na yung velocity, okay? Once na yung velocity is dinerive mo again, with respect to time, we come up with acceleration. Okay? 'Di ba? So ayan. So technically dv over dt is also or technically first order or second order na siya of distance kasi first order to 'Di ba? First order to. So first order 'yan. First order derivative. And then in this one, second order derivative. Okay? Something like that. So next, ayan. So next, meron na tayo so from distance or from displacement, once we derive it, we get the velocity. Okay? Remember that next, after we get the velocity, once we derive it again, technically papasok ngayon yung acceleration. Okay? Which is either we call the first order derivative of velocity or the second order derivative of distance or displacement. Okay, next. So technically, pwede pa natin i-derive yung acceleration. So once na din-derive natin yung acceleration with respect to time again, always guys, with respect to time, we come up with what we call momentum. Okay? Or third order derivative of distance. Okay, so third order na siya. Technically, we have up to fourth order, which is what we call, if my memory serves me right, pero check tayo ng cheat code natin, which is what we call jerk to. Para sigurado tayo. Oh, wala siya. Hindi siya nilagay. Anyway. So, jerk tawag dito. Jerk. Okay? So, ayan. Or fourth order derivative of time or displacement pala. So, ayan. Technically, so makikita nyo guys, in higher order derivatives, nagkakaroon tayo ng bago. Okay? So, pero dito sa free fall guys, hanggang from dito lang tayo, technically hanggang dito lang naman tayo. Sa free fall, ang discussion lang natin is ito lang. Okay? Ito, huwag nyo napansinin yan. Dagdag knowledge na lang yan guys. Okay, kunwari, may ano kayo, ganun. May ka-fling kayo or may kinakausap kayong bebe girl or bebe boy. Di ba? Mga ganun. Alright, kidding aside. So, ang focus lang natin guys is hanggang second order derivative or hanggang acceleration lang. Okay? So, first, so ayan. So, may idea na tayo sa mga higher order derivatives. Focus na tayo ngayon sa formula. So, technically, in free fall, we have this basic formula. Okay? Pinaka-basic formula niya na to. S is equal to, ayan, plus minus 16p squared. Okay? Yan na yung pinaka-main formula natin. Okay? So, ayan. Next. So, once na-derive natin siya, so S prime is equals to, so ito, so di ba S prime natin guys is respect to t, di ba? So, technically, lahat ng walang t, magiging 0. Di ba? Okay, so magiging 0 plus VO minus 32t. Okay? So, next. So, ito, mapapansin nyo guys, itong formula na to, ito na siya, velocity. So, ito magiging equals to velocity. Okay? Huwag natin ilagay dyan. Ito natin ilagay. Yan. Di ba? Ay, mukhang radical sign. Yan. So, next. Second order. Okay, second order of derivatives. So, ganun pa din. Mapansin nyo lahat yan, guys, with respect to time yan. Okay? So, lahat ng mga walang variable na t or time, technically equals to 0 siya kasi constant siya. Okay? So, magiging 32. Mapapansin nyo, guys, sa free fall natin, we have, or negative 2 actually. Ayan. So, technically, sa free fall natin, guys, sorry. Diba? Kung mapapansin nyo, yung acceleration natin is equals to 32. Bakit? Kasi acceleration due to gravity with respect to English units is 32.174 feet per second squared. So itong formula na to is exclusively for English units only. Okay? And ano lang niya, tawag doon? Inano niya na lang na, ano siya, tawag doon? Inisip ko yung term. Inassume or ni-round off niya to the nearest ones. Ayan, which is 32. Okay? And then, ayan. So, ayan yung reason bakit acceleration, but ganyan yung formula. Okay? So, ayan yung mga formula na magagamit natin. Pero of course, pag English units yan, nagiging ganito naman siya. Magbabago lang tong value na to. Pag meter pala, pag metric unit, magbabago lang tong 16. Magiging S plus PO time minus 4.9 T squared. Okay? And so on. So, V is equals to VO minus 9.8 T. Diba? So, V, so, A is equals to 9.8. Or A yan. Diba? So, nakita nyo na yung parang kabasican ng topic natin. Okay? So, ayan ito yung mga formula na gagamitin natin. So, ito naman, for metric naman to. Okay? So, kung nakita nyo yung mga units sa given problem is in English, of course, ang gagamitin nyo is English. Okay? Okay, so I hope clear tayo doon. Para di kayo magkamali. Okay? So, ayan. Proceed tayo ngayon sa mga sample problems natin for free fall. So, ayan. So, proceed tayo. Okay. First, ito. So, meron tayong first, a rock is dropped down a well that is 256 feet deep. When will it hit the bottom of the well? Okay? So, meron daw tayong bato na pinagsak natin. Okay? So, at what time daw siya? Wait lang, sorry. Okay. So, ayan. So, a rock is dropped down a well that is 256 feet deep. When will it hit the bottom of the well? So, technically, pababa yung ano niya. Okay. So, ewan ko, baka may nagtatanong sa inyo. Bakit? Sige, never mind. Kung wala kayong problem sa equation. Pero ayan, pakita ko lang sa inyo. Technically, so baka lang, may nagtatanong sa inyo, Sir, bakit naka-negative to acceleration natin? Diba? Bakit nga ba? Technically kasi, di ba, once di ba kung pababa, dapat pa-add yung ano. Pero ayun, because of pabawas kasi yung ano pa rin. Pabawas yung acceleration pa rin. Something like that. Okay? Pero ayun. Anyway, start tayo dito. Okay. So, ayan. So, yung problem natin, number 1, meron tayong, balik tayo sa PowerPoint ulit. So, meron tayong height or distance na 256 feet deep. And then, initial, yun nga pala, before we proceed, ano natin yung mga formula? Ano yung mga, ito, guys, yung S, asing S yan, distance. Okay? Yan yung distance. Ito, ang tawag dyan is initial distance. Okay? Initial distance. And this one, initial velocity. Okay? Then wait. So initial velocity, this one is time, of course, and so on. Okay? So ayun, so yun nga, kung yung makalimutan, yung SO, so yung may mga O na subscript, yung mga yon is tinatawag natin siya initial value. So SO is initial distance, VO is initial velocity. And then next, yung mga S or yung mga value na nasa left-hand side ng equation natin, like this one, this is what we call final distance. Okay? Final distance yan. Okay? Then, of course, ito rin, final velocity. And of course, pagdating sa freefall, guys, we only have constant acceleration. Diba? So, A is always 32. Ayan nga. 32 or 9.8 meter per second squared. Or 32.174 actually. 32.174 feet per second squared. Okay? So, proceed tayo ngayon sa unang problem natin. So, we have this problem na meron tayong bato na ihuhulog from a top of a well, 'di ba? Top of a well na merong height, okay, or distance from top to the bottom na 256 ground, 256. So technically, yung 256 natin, guys, is yun yung initial distance natin. Kasi doon tayo nag-start, 'di ba? Yun yung initial natin. Next, so dahil na-drop natin siya, guys, and no force tayong in-exert, di man nabanggit na may in-exert tayong force, so let's assume na yung initial velocity natin is also equal to feet per second. Next, of course, and final distance natin, ang tanong, so, of course, ang final distance natin, guys, is yung ground or yung bottom, di ba? So, technically, equals to 0 feet yon. Okay? Then, ang tanong naman, so, based on question, based on the problem, at what time, so actually, wala nga dun sa PowerPoint, pero at what time daw, madadrop yung, natin, at what time, the rock will hit the ground. Okay? So, ganyan yung magiging working equation natin. Okay? So 0 is equals to 256 minus 0 times time minus 16t squared. Okay? So ayan, 0 is equals to 256 minus 16t squared. 6, tama. And then 16t squared is equals to 256 and so on. Okay? So ayan. So t, as what I said, when di ba, pagdating sa square root, we have two values, the positive and negative square root of a certain number. Example like here. So we have t is equals to positive negative 4. Okay? So dahil wala naman tayong negative time, because of that, we don't have time machine. Kasi kung may negative time tayo, guys, technically, may time machine na, di ba? Pwede na yung time traveling na tinatawag. So dahil hindi pa valid, wala pa tayong time machine na ginagamit. So technically, t is equals to the positive 4. So t is equals to 4 seconds. Okay? So next tayo, guys. What if naman hinanap yung final velocity? What if hinanap yung velocity niya pagbagsak niya doon sa ground? Okay? So to get that, of course, kung gamitin natin yung formula for velocity. Ayan, di ba? Velocity is equals to VO minus 32t. Di ba? So velocity is equals to VO minus 32t. And meron tayong value ng t as 4 seconds, guys. So V is equals to negative 32 times 4. Okay? Okay, so ayan. So V is equals to negative 128 feet per second. So kaya lang siya naging negative, guys, kasi nga downward yung bola natin. Diba? Let's say we have a well here. So ayan, kuwari yan yung well. So, ayan yung well natin. Sorry, di ako mag-drawing. Diba? So, ayusin natin. Para naman mukhang ka-legit. Ayan. Korean yung well natin. Tapos yun yung ito yung lupa. Tapos, ito yung Korean yung 128 feet. Tapos may tao dito. Okay? So, yung bola. Ayan. So, dahil yung bola natin is pababa siya. Okay? So, pag ganyan. So, kaya nagkaroon tayo ng negative 1. Kaya tayo nagkaroon ng negative. Okay? Pero we can say that V is equals to 128 feet per second and going downward. Okay? So, ayun. So, yun yung reason behind ba't tayo nagkaroon ng negative na. Okay, guys? So, yan yung first example natin. So, as what I've said, diba, na-discuss ko nga yung higher order derivatives natin, guys. We have the S as distance. First order, velocity, like here. Ayan. And then, second order, ayan, acceleration. And dahil free fall siya, guys, yung acceleration natin hindi magbabago. Kasi nga, yung acceleration natin, guys, is what we call acceleration due to gravity. Whatever happens, kahit mag-exert kayo ng force doon, magbabago lang initial velocity nyo, pero yung acceleration nyo is constant yan. Either 32.174 or 9.8 meter per second squared. Okay? Malinaw na yan? So, it will never change. Okay? Constant yan. Okay? So, proceed tayo sa second, natin. So, alin dyan yung final answer? So, technically, ang tinatanong lang naman is what time it will hit the ground. So, final answer is 4 seconds. Okay, hindi lang siya naka-note doon pero ayan. T is equals to 4 seconds. Pero kung pinapakuha din yung velocity, that's how you get velocity. Okay? Kasi ang tinatanong, final velocity. Kasi meron na tayong initial Meron na tayong initial, then ayun. Di ba? So, mostly, tinatanong dyan, at what time it will hit, at what time, ganon. Okay? So, proceed tayo. So, meron pa tayong 2 problems. First, so next, ito. Assuming that second problem na tayo. Assuming that one story of a building is 10 feet. So, with what speed in miles per hour does an object drop from the top of a 40-story building hit the ground? Okay? So, ganun na ganun din yung gagawin natin, technically. Okay, so meron tayong, meron tayong building na 40 story. So first, we must know kung gaano kataas yung building natin. Okay? So sabi, yung building natin is 40 story daw siya, guys. Okay? And 1 story is equals to 10 feet. So technically, we have a height of the building. So problem number 2. So we have a building with a height. So drawing natin. So meron tayong building na may height na equals to 10 times 40, 400. Tama ba? 400 feet. Okay? Meron tayong building na may height na 400 feet. Okay? Pare. So, ayan. Para yan yung building natin. So, may 400 feet tayo. Next. Ang tanong, what will it be? Ano yung magiging velocity niya once na na-reach ng bola yung, so let's say we have a person here again. Meron siyang bola. Once na dinap mo siya dito. Okay? Di ba? Actually, same lang siya nung first problem natin. Okay? What do I mean by that? Pakita natin bakit same na same. Okay? So, ayan. So, ayan. So, yan. So, first, meron tayong, as what I said, yung formula na to, ayan, balikan natin. Ayan yung final distance natin, ayan yung final velocity, and so on. So, same lang yung gagawin natin. So, ang una natin gawin, dahil kailangan natin ng time for velocity. Diba? We have formula for final velocity na VOT minus 32T. Diba? And dahil kailangan natin ng time para makuha yung final velocity, makukuha natin siya doon sa unang formula, which is S is equals to plus, diba? Minus 16T squared. Okay? So, meron tayong initial height na 400 feet. Meron tayong initial velocity na 0 feet per second. And then, meron tayong final height na 0 feet. And ang hinahanap, velocity in miles per hour. Okay? So, ayan na yung magiging working equation natin. So, first, technically, we only have 2 working equations in Freefall. Okay, ayan lang, 1 and 2. So, first, solve muna natin kung anong time siya babagsak. Okay? So, S is equal to 400 plus 0 minus 16T squared. So, 0 din to, di ba? So, 16T squared is equals to 400. Okay, divide both sides by 16. So, T squared is equals to, calculator, 25. Okay. So, T, as what I said, we only get the positive value. Okay. So, T is equals to 5 seconds. So, may value na tayo ng T natin. May time na tayo. So, once we know the time, it will hit the ground. We can now get the final velocity. Okay. So, V is equals to, technically, dahil 0 naman yung final first velocity natin, so magiging negative 32 T lang siya. Diba? So, V is equals to negative 32 multiplied by 5. So, V is equals to 160. Tama? 160. 160 feet per second. Pero ang hinahanap sa atin, guys, is miles per hour. So, ang magandang conversion yan is, tama ba? Is multiplied by 1522. Okay? Ayan. Ayan na yung pinaka-conversion. So, tama. Mababa siya. Teka, check na natin. Okay. Ba't wala yung negative sign? Okay lang kahit wala yung negative sign kasi nga, yung negative, so, di ba, velocity. Ano ba yung velocity natin? Velocity is a vector quantity. So, once it is a vector quantity, technically, it is a quantity that with directions. Okay? So dahil downward yung ano natin, guys, yung velocity natin, sabihin 162 feet per second siya downward. Okay? Pero as what I said, pwede na nating i-neglect yung negative sign kasi it only denotes, okay? It only denotes the direction. Okay? So ayun. We can neglect. We can neglect the negative sign. So ayun. So ayan. So equate natin to. So 160 times 15 divided by 22. Which is equal to 109.091 miles per hour. Teka, natin. Make sure ko lang. So 1 mile times per hour. So mile feet times hour seconds. 5 to 80. Tama. 5 to 80 divided by 36. Oh, tama. Ayan, tama yan. So ayan na yung pinaka-conversion natin. Okay? Feet to mile, 15/22. Pero pag mile per hour to feet per second, 22/15. Okay? So ayan na yung final answer natin. So next tayo, next problem. Last problem for rectilinear motion or free fall. So number 3. So itong last problem na to, medyo tricky siya kasi madami siyang hinahanap. Okay? So, a rocket is shot. So, kaiba siya doon sa unang dalawang problem. Okay? So, sabi, a rocket is shot straight up into the air with an initial velocity of 128 feet per second. So, pataas naman siya. First, how far has it traveled in 1 second? Okay, next, or in 2 seconds. Next, when does it reach its maximum height? And then next, what is its maximum height? And then, when does it hit the ground again? And then, what is its speed when it hits the ground? So, umangat siya, tapos bumagsak din siya ulit. Okay? So, tatandaan nyo yun, ha? So, first, para di kayo malito, i-note muna natin kung ano yung mga given. First, technically, we have a initial velocity. Ang initial velocity natin, talingan ko lang. Initial velocity na 128 feet per second. Okay? Initial velocity ka, 128. So, 128 FPS. And then, may initial distance ka na 0 feet. Okay? Kasi from the ground Diba? So, ayan. So, first, ang inatanong, balik ulit tayo doon. How far has it traveled in 1 second? So, ang gano'n na kalayo na travel niya in 1 second, tsaka in 2 seconds. So first A. What is this S? Okay. When T is equals to 1, T is equals to 2. Diba? Ano yung final velocity niya in 1 second? Ano yung final velocity niya in 2 seconds? Okay. Next tayo. Ano pa? At what time? Okay. At what time it will reach its maximum height? So, paano natin ngayon malalaman yung maximum height niya? Okay? Paano natin ngayon malalaman yung maximum height? Malalaman natin yung maximum height niya once na yung velocity niya is equals to 0. Di ba? Technically, once you reach, you will reach your maximum height once na yung velocity mo is equals to 0 na. So, T when final velocity is equals 0. Okay? Di ba? I hope nagigets niyo yung idea. Nagigets niyo yung ano. Next, C, ano yung ngayon yung maximum height niya? Di ba? So, what is its maximum height when V is equals to 0 din? Di ba? Next. Next, when does it hit the ground? Okay? At what time naman daw niya may hit yung ground? So, technically, medyo tricky tong tama, wait nga lang. Tama, di na, di ba? Di na ba? Tama, D. When does it hit the ground? So, technically, paano natin malalaman? So, technically, para makuha natin yung time na yon, i-add natin yung time na pag-angat niya, time when, time total, di ba? T, kailangan natin makuha yung time na pag-angat niya, okay? Tsaka yung time na pagbaba niya at this speed din, syempre, di ba? So, V is equals to 128 feet per second. So, ito, T, ito yung pag-angat, ito, pagbaba. Pag-a-add mo yan. So, T is equals to, ayan, ganyan. Okay? So, next tayo. Lastly, ano ngayon yung, syempre, ano yung what is its speed when it hits the ground? So, technically, actually, E is equals to 128 pa din yan. Okay? Magiging 128. Syempre, di ba? Kung ano yung pag-angat mo, ganun yung pagbaba mo. Hindi magbabago at hindi magbabago yan. Technically, D natin, technically D is times 2 lang nung time nung pag-angat. Okay? Pero pakita na din natin, di ba? So, solve na natin siya. So, first, A. So, ano yung final distance niya at this time? Okay, so A, S is equals to initial plus VOT minus 16 T squared. So, 0 plus 128, 1, di ba? Minus 16. So, 128 minus 1, 16. So, S is equal to, may height siya na, 128 minus 16. May height siya na, 112. Okay? Next. Next tayo. S is equals to 0 ulit plus 128 times 2 minus 16 times 4. Di ba? Kasi 2 squared. So, T is equals to 1. T is equals to 2. So, S is equal, sorry, nakakain ko ng oras. So, ilan to? 128 times 2, 256. 256 minus 4 times 16, 64. 64. So, S is equal to ilan? 56 minus 64. 192. Okay? So, ayan na yung mga sagot sa A natin. So, at T1 second, at 1 second, height natin is 112. At 2 seconds, ang height natin is 192. So, next tayo, V. So, V. So, find anong time. So, technically, meron tayong initial formula na S is equals to, ayan, plus VOT minus 16T squared. So, meron tayong value ng VO, which is 128. So, magiging velocity is equals to 128 minus 32T. Di ba? Ayan yung working equation natin. So, dahil V is equals to 0, so magiging 0 is equals to 128 minus 32T. Then 32T is equals to 128. So T is equals to, kasi kailangan natin ma-reach yung initial velocity kailangan natin ma-reach yung zero velocity para yun yung maximum height natin. Okay? Kasi tendency nun, once na nag-zero siya, ang tendency, babagsak na siya. Okay? Diba? Once na ma-reach niya na yung zero, babagsak na din siya. Okay? Matik yun. Ano na yan? Common sense na yan. Okay? So, next tayo. So, T is equals to 4 seconds. So, yung time na na-reach niya yung maximum height niya is equals to 4 seconds. Okay? So, we can technically solve S by using this. So, dahil yung B natin is with respect to initial, final velocity as 0. So, technically, T is equals to 4 seconds. Diba? So, S is equals to SO plus VOT minus 16T squared. Diba? So, 0 plus 128 times 4 minus 16 times 16. So, S is equals to 128 times 4, 512 minus 256. Tama ba? 256. So, S is equal to 256 feet. So, technically, Yung D natin, as what I said, yung D natin is times 2 lang yan. Pero pakita na rin natin. Di ba? So meron na tayong time sa maximum height niya. Ayun na yun. So next ko natin yung pagbagsak naman. So, di ba? So meron tayo final velocity na 128 is equals to. So yung D natin, so yung sa D, magbabago na yung formula natin. Meron na tayong wala tayong S equals to, meron tayong SO na 256 and then VO na 0. Okay? Tapos meron tayong S na 0 din. Okay? Then V na 128. Actually, wala tayong value ng V natin. Solve pa nga lang natin. Pero technically, ganyan yung magiging working equation natin. Okay? So from here, so magiging 256. So ito bababa na siya. Okay? So magiging pababa na to Ito, bola natin pababa na siya. Sa D, itong formula na to, pababa na siya. Okay? Pinapaalala ko lang, plus VOT minus 16T squared. Okay? So pababa na siya. So 0, 256 plus 0 minus 16T squared. So 16T squared, 256. So T squared is equals to 16. Ayan. So, T is equals to 4 seconds. So, of course, di ba? Kung ano yung time na pag-angat mo, hindi yung time na pagbaba mo. So, technically, T is equals to 8 seconds. And of course, E, by merit lang din, di ba? Is equals to 128 feet per seconds. Okay? So, ayun. Di ba? Ganun lang naman. Yun lang naman yung pinaka-basic na ng equation natin. Okay, so that's all for Freefall. We will continue our lesson later. So, meron tayong lesson later na optimization and then related rates. So, save ko lang to, guys. And you may now leave the Zoom meeting para ma-save. Actually, kahit hindi. That's